All right, we're going to be looking at section 1.2, displaying quantitative data. We're going to mainly focus on dot plots and stem plots. So here we're using this data here, 2012 U.S. Women's National Soccer Team, the number of the goals they scored in the 12 months prior to the 2012 Olympics where they won. Here are the steps in making a dot plot of that. Draw a horizontal axis, a number line, just like this. Label it with the variable name, number of goals scored. You can have it there, or you can have a title like this. I think I prefer the title. Draw a horizontal. Scale the axis. We went by ones because we had small numbers. Had extended a little bit because we had some bigger numbers here, but just one tick for each one value. You can label all of them or just every other like this. Mark it out above the location, so put them on there, put some dots on there. So there is no y-axis in a dot plot, so don't give me one. Other than that, we're looking good here. We also don't have to start it at 0 with the dot plot. You start at whatever values you want to start with. All right, moving on. In any graph, look for the overall pattern and for striking departures or outliers. Describe the overall pattern using shape, center, and spread, and talk about outliers. That is SOX. Shape, outlier, center, spread. Shapes can be skewed right, where most of the data is on the left, a couple extreme values on the right. Vice versa, skewed left, where we have some very small values, where most of our values are to the right. Normal, when it completely looks like our bell curve. Uniform, if it's straight across, each thing is equally likely or happens the same amount of times. Bimodal is where we have two peaks because there were two most prevalent values. Two modes, bimodal. Those are our shapes. Outliers, we will find a formula to find outliers at a later date. But outliers are just values that are extremely big or extremely small compared to the rest of the data. The center could be mean, median, or mode. Most of the time we'll use mean, sometimes we use median, we rarely ever use mode. The mode is the peak of the shape. Mode's here, and here, and here, and here, and both of these. And then we have to look at the spread. Standard deviation, variance, which we can calculate now, IQR, which we'll get into in a little bit, and range, where you just do the maximum minus the minimum value. So again, when we describe a distribution of a quantitative shape, use SOX. So here, if we're looking at this data, we have the shape on that one. Got a peak at 4, a single main cluster of dots between 0 and 5, a large gap, a little more than what you need. The shape is skewed right. Most of our values on the low side, we got a couple on the high side. So it's skewed right. The center, you can find the midpoint of the 25 values, and that's the 13th value, because it's, well, that's the middle number. And the midpoint is 3. Does 3 represent this data well? Probably not too bad. So we can have 3 as our center. And then our spread, 0 to 4, our range is 14 goals. Pretty straightforward. And outliers, 13 and 14 are possible outliers. So we label them because maybe they are, maybe they're not. But they're a lot bigger than the rest of the numbers here. How do the numbers of people living in households in the UK and South Africa compare? Here is our data. Household size for each of South Africa and the UK. So we found the range to be 23 and 4. Again, that's the biggest value minus the smallest value for both sets. We found our shapes, and we use all this to compare. So that means we need to have a relationship between the two things. South African households is skewed right, while UK households are more normal. We have a possible outlier at 26 for South Africa, but UK has none. The center of households in South Africa is about 6, which is greater than the 4 for which UK has for a center. The range of South Africa data is 23, which is over 5 times as large as the UK spread, which is 4. So very, very different. And that's how we compare using socks. Now we're taking a look at how many pairs of shoes a typical teenager has. So we're going to build this into a stem plot. First, we find the stems. It's the leftmost number. And here, that's the tens position. So 1, 2, 3, 4, 5. Then we add the leaves. So we have a 19, so 1, 9. A 13, 3 13s actually. So we have 3 3s here. Go with that 1. So these are our 1 values. And then we need to put them in order. It's always least to greatest. And we always, always, always want a key. So 4/9 represents a female student who reported having 49 pairs of shoes. It wasn't 4.9. It wasn't 490. It was 449 because the key told us so. So here is our stem plot, our key, and that's basically it. Here we have a split stem plot because we have 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. They've doubled here. Probably because there are a lot of values up in the 0 and the 1, and we didn't want to make it look too busy. The fact that it's back to back means we have 2 sets, males going this way, females going this way. And females kind of awkward to gauge. This last number here is not 75, but 57. Remember, the middle column here are the tens position. So using these two, we're going to use socks and compare the 2 sets. So with regards to how many pairs of shoes we have, the data for the male is skewed right, where the female data is more uniform. Males have possible outliers at 35 and 38, and females had no obvious outliers. Center for female is 26 or so, which is much higher than the male's 7 or 8 pairs. The range of females is 44, whereas the range of males is less at 34. So females have more shoes on average, a wider range in general, and that's how we're going to be doing this stuff.